last time we got introduced to the idea of logistic regression and classification, whatever that means, right? Now I want to tell you a little bit more about generalizing this. So what we were doing just now is we were using one thing that we know to predict one thing that we don't know. I want to broaden your mind and take you beyond that idea of just one-to-one mapping. Um, so what we did was we were trying to let's say we were trying to predict um, rain. Is it going to rain tomorrow? Right? Um, and our input was, let's say, the day, right? Day of actually let's say it was the month of year, right? So we're using this one thing to predict this one thing. We know this and we want to find out what this is, or we're trying to predict what that is. And this is a classification task. And so just to remind you, we would be doing a sigmoid of mx plus b, where let's say m and b are given to us, they're constants, and this is our variable input. Whatever the input is, which is the month of the year, we'll feed that into here, multiply by m, add b, apply the sigmoid function, which is just, a fixed function. Whatever does basically um, this is the function that it executes, 1 over 1 plus e to the negative of whatever the input is. And after this, we would get a probability of whether or not it would rain, and then we would make a decision based on whether or not it's greater than 50% chance that is it going to rain or not. Okay. Um, and so we have this one-to-one mapping, but we can actually feed in more information in order to get a better idea of whether or not it's going to rain tomorrow. Maybe instead of just the month of the year, we also have the year. And so because of climate change or whatever, there is increased chance for like rain in a part of the world where maybe it wasn't so a couple of years ago. And so that trend, capturing that trend might be helpful for us. Or maybe the day of the of month. Maybe there's a monsoon season that should be starting mid-July, but it's before mid-July, and so it's at the beginning of July, and so we don't think that there is much of a chance for rain before then. Or maybe there's like wind speed, which is from some like from wind speed today that we calculated based on measurements or sensors or something like that. Maybe we also know whether or not it rained today, right? And so all of these are possible things that we could use to inform our approach of predicting whether or not like it will rain tomorrow. Um, there's also another thing that we could do, which is have multiple outputs. Rather than just having to know how much, sorry, if it's going to rain tomorrow, we can know how much rain in inches or centimeters or something like that. How much do you think it's going to rain tomorrow? Maybe we also want to know the wind speed, but for tomorrow, or the temperature. What is the temperature going to be like, highs and lows tomorrow, right? We could have multiple outputs, right? And you can see how this would be advantageous, right? Having multiple outputs would allow us to make a lot of other decisions rather than just like based on whether or not it's going to rain tomorrow, make other decisions as well. And having more inputs would allow us to better use the data that we know to have more accurate predictions of the stuff that we don't know. And so there's more stuff that's getting inputted and more stuff that's getting outputted. And that's the power of neural networks. Because like I showed you the example of linear regression and logistic regression where you have one input and one output. In linear regression, you can actually have linear regression. You can actually have like multiple inputs, but you can only have one output. no matter um, how many inputs you have, you can only have one output. In logistic regression, you can have multiple inputs and only one output. So many to one, I guess. But and the one being a sort of probability whether or not it's going to rain tomorrow, that kind of thing. But in neural networks, you can actually have uh, multiple inputs and multiple outputs. Okay, so that's the power of neural networks. And next time, what I'll tell you is a little bit about how you take multiple inputs and feed that into linear regression. And it's actually the same thing for logistic regression. And then we should be ready to go on to neural networks.